Hi, my name is Jeff Socek. I'm the director here of R&D at Felt Bicycles, and we're going to talk a little bit about manufacturing processes and the different applications and how we use them to design and build bicycles here at Felt. So at Felt Bicycles, we have two different types of manufacturing process for making our carbon fiber bicycles. For the last 5 years, the F1 bike has been a great success for us in the fact that it's extremely lightweight and has fantastic ride quality and stiffness. You can see here, this is an example of the front triangle of the F1 bicycle. This is a process called Modular Monocoque process. We also have a new process this year called Dynamic Monocoque that we'll be talking about in a little bit. But first, let's review Modular Monocoque. As you can see here, the entire front triangle is made in one piece. This is where we get the monocoque part from, and the fact that the top tube, head tube, down tube, bottom bracket lug, seat tube, this is all made at one time. The carbon fiber is all commingled together, and what we basically do is apply the seat stays, the chain stays, and the dropouts afterward, overwrap it with more carbon fiber, and co-mold those pieces together, making an entire structure. This is fantastic for making a very lightweight frame. Like I said, we've been at 900 grams with great stiffness. So when we designed the new F1 bike, we also needed to come up with a new process. We talk about dynamic monocoque process in the fact that we take this frame and continually refine it. If you'll see the new F1 here, it's actually made in additional pieces. We actually split the front triangle up into multiple items. It's still monocoque in the fact that the top tube, head tube, and down tube are molded in one part to give incredible stiffness. But then we've also molded the bottom bracket, chain stays is one piece monocoque. These parts are then joined together, overwrapped, and co-molded into one final process. Well, why do we do that? We do that in order to optimize the layup of the frame. When you look about monocoque construction, you have to look at the bladder process. Typically, the way we do our frames is that you have an internal bladder that is inside the tubes of the bicycle. And the fact that a clamshell mold is closed up on the frame, the air bladder is inflated and it pushes the material against the inside of the mold. This is what compresses the carbon fiber and makes the frame come out nice and finished to the actual size. Well, you can imagine when you're talking about a frame like this, it's much more complicated in the fact that you have different intersections in different areas of the bicycle where it's difficult for that bladder to get into all the small corners, change directions, etc. So what you do is you end up a little bit of extra material in some of the corners, and the layup is not as quite as refined because you have these different corners in different areas. When you go with the dynamic monocoque process, you can see the part becomes much simpler. You can see it's a very straight tube with an easy place for the bladder to exit in both locations. That allows us to really fine-tune every bit of this front triangle and not have any excess material at all. So you can see that we have a much more simple front triangle. We then have a very simple bottom bracket area as well. By again utilizing the shapes and utilizing the bladders, we can make the layup more efficient. The parts are then co-molded together, overwrapped, and then re-put back in the oven where they're all molded into a final piece and a final monocoque section. So you can see it's a similar process as before. We had the modular monocoque where the entire front triangle was made as one piece and the rear stays were co-molded on after. Now we have the front triangle broken up into different pieces and again co-molded afterward. Again, what this does is it allows us to have more refinement of the internal structure and allows us to make the frame that much more accurate. There's no extra intersections or any extra material inside the frame that can add to weight or decrease the stiffness of the frame. So we already talked a little bit about monocoque processes and the different types that we have at Felt Bicycles. We have the modular monocoque process and the dynamic monocoque process. Well, the second bit of the puzzle is the inside-out technology and what this offers to the consumer and how we can apply this to these different processes. Again, we talked about dynamic monocoque being a process that allows us to optimize the internal structure and the bladder routing. Well, inside-out technology is in addition to that. It's basically a second step that kind of works hand in hand. As we talked before, you can see that we use an internal bladder system in monocoque production. This bladder is, you can see, kind of rigid, not very flexible. So you can imagine that inside the frame you're going to see some wrinkling or maybe some areas where you go to the intersections where the inside of the frame is not quite as nice. Well, what typically that means is you'll have a little bit of extra resin or a little bit of extra material. It's not doing anything. It's just kind of there adding some weight and not really helping the stiffness or the strength at all. Well, how do you make that better? You do that by going with what we call inside-out technology. What you can see here is a polyurethane internal mold, if you will. So you have two different processes going on. We talked before about how you have the clamshell molds closing up and the internal bladder expanding out the carbon to cure it into the final shape. Well, with inside-out technology, this internal mold is actually put inside the carbon, and the nylon bladder then runs through this. You can see there's an entry point where the bladder runs in, and then the bladders come back out. What this does is let this area where there might be more wrinkling or less refinement due to the nylon bladder become much more refined, much smoother inside. So basically in the critical areas of the bike, like the head tube, the bottom bracket area where there's a lot of stiffness and strength required, you want a lot of refinement and you don't want a lot of excess material. By using inside-out technology, using these internal bladders, we can make the inside of the frame as beautiful as the outside of the frame, maximizing the stiffness and minimizing the weight. We talked a little bit about how inside-out technology and dynamic monocoque construction really go hand in hand with each other. And the reason why is because of how you have to remove these internal molds or these internal bladders afterward. You can imagine that when you see a part like this, a bottom bracket, there's very large open sections here, where it makes it much easier to remove this internal bladder. When you have the current process, the modular monocoque process, you can see there's no openings in the frame in this area. So it's a lot harder for us to employ the use of inside-out technology in the older process. So by utilizing dynamic monocoque construction, we can use these internal molds in more areas and therefore increase the ability of the frame to be as light as possible and as stiff as possible and as strong as possible. Again, it comes down to refinement and optimization.